In this video, we'll be exploring a key concept in angular kinematics, torque. Throughout the video, we'll demonstrate torque by using real-world examples, physical demonstrations, and clear visuals to help you understand how torque works in a practical way. To begin, here is a textbook definition of torque.
So what is torque? Torque is a vector quantity that represents the twisting or turning effect of a force around an axis. It's determined by the magnitude of force and perpendicular distance to its line of action. You can see the equation can be defined as torque equals force times radius.
Now, here's a personal definition of torque that helps us remember the concept.
Torque is how much twisting force you apply. The further from the pivot point you apply the force, the more torque you create, like opening a door from the handle versus near the hinges.
For the remainder of the video, we will provide a variety of physical demonstrations that portray real-world examples of the concept of torque, starting with the example mentioned in our personal definition. For this example, Rachel is acting as the door, while Alicia attempts to rotate the door open by applying force to different locations. She begins by applying force to the shoulder and then to the wrist. Let's slow it down. Notice the difference when force is applied at the shoulder versus the wrist. By applying force farther from the axis of rotation, we generate greater torque, making it easier for rotation to occur. Let's take a look at a similar example of this using arm wrestling. In this demo, Alicia and Rachel are arm wrestling, but Alicia is applying force at different locations. She starts by applying force farther out at the forearm and then at the hand. In this demonstration, both individuals may be applying similar force, but Alicia has the advantage of leverage. By initially positioning her grip farther out on the forearm, she increases the distance from the axis of rotation out the elbow joint. That longer moment arm generates greater torque, making it harder for Rachel to overpower her. This illustrates how in rotational movement, strategic positioning can outperform pure strength. In other words, in a battle of torque, leverage beats raw force. In this example, Rachel is performing a plank while Alicia adds a weight to different locations. In this first clip, Alicia places a 45-pound weight over Rachel's hips. In the second clip, she places the same weight over Rachel's shoulders. In this demonstration, the weight remains the same, but its position changes. When the load is placed near the hips, it sits closer to the center of mass and the shoulder joint, creating minimal torque. But as the weight shifts towards the head, the moment arm increases. This added distance amplifies the torque demand, requiring the shoulder muscles to generate greater force to maintain stability. It's a clear example of how torque isn't just about how much weight you move, but where the weight is applied. While physical demonstrations are valuable, here are several real-world examples that illustrate how torque is applied in practical settings. The first real-world application is injury prevention. When torque is poorly distributed or poorly controlled, the risk of injury rises dramatically. Take the ACL tear, one of the most common and devastating injuries in sports. It often occurs when torque at the knee exceeds what the joint and surrounding muscles can handle. In rapid deceleration, landing, or cutting, if the athlete can't generate sufficient internal torque to stabilize the joint, structural failure occurs in seconds. Understanding torque isn't just about movement mechanics, it also applies to injury prevention. Another real-world application is performance optimization. On the performance side, torque is a tool, and when applied strategically is a game changer. Coaching cues, like spread the floor during squats, generate external rotational torque through the hips, creating joint stability and efficient force transfer. In Olympic lifts, cues like hip drive maximize internal torque from the posterior chain, propelling the bar with power and precision. Torque efficiency separates average movement from elite performance. It's the difference between simply moving weight and moving it well. In conclusion, torque is the silent force behind every athletic movement. It's what drives rotation, creates leverage, and allows muscles to produce motion around joints. From a pitcher's windup to a sprinter's first step, torque powers performance. It doesn't just move the body, it stabilizes it, protects it, and helps prevent injury under load. So the next time you lift, rotate, or pivot, remember, it's not just motion, it's torque that moves you. Thank you for watching. We hope this video provided a clear and engaging look at the concept of torque.